Hello, Hawks. Okay, so this week we're doing the whole entire Geometry Foundations unit. Um, you'll probably notice that includes the angles section that we did before. All of this stuff here, right, these are videos. If you're getting stuck on something, these videos more or less walk you through the practice problems. The practice problems, try them out. My recommendation, like if I were stuck in your situation, which I agree sucks, I wish I could physically see you guys every day. I wish you could be at school right now. I would just scroll all the way down to the very bottom to where it says unit test. And then just take the unit test. That's what I'm going to do right now. When you take the unit test, for me it's going to be a little bit wonky if I take the unit test, because it'll, I'll just take it completely from scratch. Let's just cheat and just copy this. That's totally what I wanted to do. Okay. So I'm not even logged in right now. So if I go down to the unit test, it's going to go over every single thing that it has. Okay, it's saying that I should plan upward to 30 minutes to do this. Let's go. Okay, find the area of the shape below. For each of these, work through them slowly. Think about them. When you're done, it will populate all of these standards here, right? It'll show me how I did, right? I haven't done anything yet, so I still have 0 out of everything, right? I have nothing right. Okay, so we're just gonna start off. Okay. If you have the ability to draw and stuff like that, or get out a piece of paper. Where's my writing pen? I do not see my writing pen. Okay. Hold on. There it is. Sorry about that. Okay. If you have, you can draw right on here. I'm using a writing tablet to make it easier so I can actually see what I'm doing. Notice this is 2 by 2, right? So 2 by 2. It's a triangle, right? So we know that's base times height divided by 2. Or in other words, 2 times 2 divided by 2, that's just 2. So that's this triangle right here. This triangle is the same triangle, so this is 2, this is 2. This has a base and a height of 2, and it's a rectangle, so it's 4. 2 plus 2 plus 4, or 2 plus 4 plus 2 is 8. So I can just put in the 8 units. And we're good to go. Could 2.8, 4, and 2.8 centimeters be the side lengths of a triangle? Now, if you remember the triangle inequality, two sides of a triangle, I don't like it there. Two sides of a triangle, right, has to be both bigger than, the other side of the triangle. And it has to be smaller than the other side of the triangle, right? So we have all 3 sides, right? We have a triangle like this. Oh, it sometimes complains about stuff. Okay. All right, and we're saying, oh, okay, that's stupid. It won't write in the answers. I figured that out the other day. Okay, they're saying this is 2.8, 2.8, and 4, right? Well, 2.8 plus 2.8. Oh, sorry, this is wrong. Just look at this. Ignore that for a second. The other triangle inequality is that if you subtract two sides, that has to be... I don't like this either. We're just going to use this for right now. And if you're still not sure, check more sides. And you know what? All I'm doing is screwing everything up. Will it clear the whole thing? Clear the whole thing, please. Okay. It's a good thing I don't teach people math for a living. Okay. So two sides added together, right, have to be bigger than the other side. Why? Because this is the long way, this is the shortcut. Right? Right? If this is 2.8 and this is 2.8, then whatever this is, it better be less than 2.8 plus 2.8. If this is 2.8 and this is 4, then it better be, then this here better be shorter than this here. Right? So we're going to check that out. 2.8 plus 2.8, is that greater than or equal to 4? Yes. What about 2.8 plus 4? Is that greater than 2.8? Yes. Okay, so this works just fine. Yes. The angle measurements in this diagram are represented by the following expressions. 8x minus 8 and 5x plus 25. We're noticing these are corresponding angles, so they have to be the exact same. So in other words, we know that 8x minus 8 equals 5x plus 25. Okay? I'm going to get rid of the 5x right here from both sides. Get rid of it from here, and I only have 3x left. Get rid of it from here, and I just have, oh, and we still have the minus 8. And then over here I just have the 25. Add the 8 to both sides, right? We have 3x all alone. 25 plus 8 is 33. Which means x must be 11. Okay, and we want to know the measure of angle B. We're actually going to do both of them because they're supposed to be the same. If I plug in 11, I should get the same thing. 88 minus 8 is 80. 5 times 11 is 55. 55 plus 25 is 80. So I should be putting in 80 degrees. Check. Next question. The diameter of a circle is 16 units. Okay. Draw a notorious Nelsky circle. It's not liking my writing tablet right now. Okay, whatever. Draw a line straight through. Right. Here's the center. The diameter is the whole way across. So the whole distance is 16. The radius is only half that, so the radius is going to be 8. That's mostly remembering a definition. The radius is half is the distance from the center to the side, and the diameter is the distance all the way across going through the center. Okay, select the most precise and correct definition of perpendicular line among those that are given. Notice right here that it says precise and correct. That means one of these might be technically right, but it might not be completely right. Okay? Two distinct lines are perpendicular if they are as far from being parallel as possible. I don't even know what that means. So this is not a very good answer, right? So we're just going to ignore this. The one up here, two lines are perpendicular if they have opposite slopes. What do they mean by opposite slopes? Right? We're not really sure what that is. Two lines are perpendicular if they meet at one point and one of the angles at their point of intersection is a right angle. Right? We know that you have to have a right angle. You have to have a 90-degree angle to be perpendicular. This one is also saying you have to have a right angle or a 90-degree angle. This is going to be it. Notice it says one of the angles. Well, if one of the angles is a 90-degree angle, we know the other ones are going to be as well. That's why it's just saying one. it's kind of a weird way to word it. I would probably word it 2 lines are perpendicular if they meet at one point, and the angles formed are right angles. But this definition is also very precise and technically correct. The present shown below is a cube. Find the surface area of the present. The surface area is the area of all of the sides of this cube. Well, a cube has 6 sides, and so if we just figure out one side, right, and one side's just going to be, what, 20 times 20? Length times width. So that's 400. And there's 6 of those sides. All right, so we're going to get 24, wow, that's a terrible zero. 2400, right? And then we're just going to check that, and then we're going to keep going. Okay, in the following diagram, HI, this line, is parallel to JK, this line. Okay, these two lines are parallel, and we want to figure out this angle. All right? Well, look at this right here first. This big triangle, JAK. Notice that this angle right here, you know what, actually, let's draw it the same exact color as this. This is also, oh, that's terrible. This is also 60, 67 degrees, right? Because these two angles are in the same exact spot. These are corresponding angles. That also means that this angle, let's change the color again to this blue that they're using. All right, this angle right here is also x. So if we can figure out either of these x's, we're golden. Well, notice 67 degrees, 46. Well, a triangle, right? We know that 67 plus 46 plus x has to be 180 degrees, right? Because that's my big triangle, HJK. It's actually also my small triangle. And so now all I need to do is just add these two together, right? 60 plus 40 is 100. 6 plus 7 is 13. So this is 113 degrees plus x, and that equals 180. Get rid of the 113, right? And we're going to be left with x is equal to 67 degrees. Okay? And so we're just going to plug that in. 67 degrees. Double check. 67 plus 67 is 134, and 134 plus 46 is 180. Check. We got it right. Okay. Measure of angle AOC is 104, so the big angle is 104. AOB, that's just this one, is 7x plus 30. BOC is 9x plus 42. So this time, we're actually adding some stuff up together, right? We're taking the 7x plus 30, and to that we're adding 9x plus 42, and that's going to equal 104. Okay, well that's really 16x, right? And plus 72. Right, that still equals 104. Get rid of the 72 from both sides. 16x equals 32. Well, then that means x has to be 2. Okay? We need to know the measure of BOC, this one right here. Well, that's not bad. All we have to do is plug in the x value right here. Right? So we have 9 times 2 plus 42. Well, 9 times 2 is 18 plus 42. Let's write all this work down here instead where we can read it. Okay, we have 9 times 2 plus 42. 9 times 2 is 18 plus 42, and that equals 60. So the angle BOC should be 60 degrees. Let's type in 60. And then keep going. What is the sum of the interior angles of the polygon shown below? This should feel really straightforward. Let's do that. Okay. I'm going to cut this up into triangles so that you guys can see how I'm doing this. Right? Notice this is still the angle of the pentagon, 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 still the angle of the pentagon. Yeah.
I flipped it over on my toe.
Okay, well, why don't you go dry your foot off? Honey, I don't see any blood. Go dry your foot off and come back to me. Okay, dry your foot off, come back. This is 180, this is 180, this is 180. So all together, we add those up. 180, 180, 180, and we're going to get 540. This is the angles all added up together. There are other ways to solve this. This is the one I consider to be the easiest. Let's go ahead and show you another way. Another way you can do this is, right, just draw a line straight across over to the middle, straight across over to the middle, straight across over to the middle, straight across over to the middle. Now imagine that all of these met in the same place. You know what, screw it. Let's just do it again. Okay. So the middle is right about here. It's not filling a point in for me. The exact middle of the shape. We're gonna, see, I'm going too high on that one. This is hard to do. Oh, okay. Screw it. I'll just draw it super lame. So that's okay. Okay, so middle. Middle, assume I actually went through the point that time. Middle, we have one more. Middle, okay? Right, they all went right, okay, they all went right through here, right? Well, that gave us a bunch of triangles. This one's 180, this one's 180, this one's 180, right? In fact, if you count them, you'll notice we're going to have 10 of these. 10 times 180 is going to be 1800. Oh, but actually, this is not a part of the triangle's angles right here. This part isn't. So really, there's only these 5 triangles. Right? This triangle, the same exact one here. This is 180. This is 180. Do 5 times 180. And then notice here in the... I can't do this. Right, each of these is 180. Each of these is 180. This is 180. This is 180. And all of their angles are part of the pentagon's angles except these. Remember, a circle's 360? This becomes 900 minus 360, and that's 540. I would recommend doing it the way we did it at the start. I would go back and pause it so you can see it cut up like a shell. That's definitely the easiest way. But this is another way I've seen a lot of people do it, so I don't want you to not see that way. Check that answer, move along. Are the points H and L collinear? Collinear means on the same line. Notice H and L are both on the line L. So yes, they are collinear. what is the value of the marked angle marked with X? Notice this is a rhombus. If we were to extend these sides, all right, and get our parallel lines that we actually have, right, then this would be 87 degrees right here, which means this must be 93 degrees. Extend that here, right? This 87 is going to come over here to this 87, which means this, which is a vertical angle, must also be 87. Right? And we're just doing that looking at the parallel lines because we know opposite sides of a rhombus or of a parallelogram must be parallel, so we can use the alternate interior angle theorem and corresponding angles. We actually just used corresponding angles, right? 87 matches 87, 87 matches 87. A circle with radius 2 centimeters sits inside an 11 centimeter by 12 centimeter rectangle. What is the area of the shaded region? Round your final answer to the nearest hundredth. Well, 11 times 12, do that part first, right? 11 times 12, that's 132. So that's the whole rectangle. And then the area of a circle is pi r squared. If you don't remember why it's pi r squared, I would recommend look up why is the area of a circle pi r squared. And the way we're going to do this though is r squared. The radius is 2, so we're just going to do 4 pi. Pull up the little internal calculator they have here. Oh, hide the thingamajigger so we can do it. Show calculator. And we want to do 4 times pi equals, and it's saying 12.566. I know it says nearest hundredth. We're going to keep the 12.566 for right now. Okay? So we have 132 minus, let's write this 12.566 off to the side. 12.566. I'm even tempted to write the 37. All right, so let's do that. Let's clear this. And we're going to do 132 minus 12.56637. I'm going that many digits because I want to make sure that when I round, I'm not screwing myself, okay? 119.43. So 119.43. 119.43. And let's get rid of the drawing and hide the calculator. 119.43, check. Next question. What is the circumference of the following circle? Well, remember pi is just the ratio of the circumference to the diameter. In fact, this is actually what pi equals. Equals the circumference of a circle divided by its diameter. Well, in this case, I'm going to multiply both sides by the diameter. And now I've got the circumference all alone. So if I do 3 times pi, I'm going to get the circumference. Okay, let's pull up the calculator again. Remember, we're doing 3 times pi. This is my circumference, 9.42. Okay, 9.42. It's not telling me what it wants my answer to be, so it may want it to be exact. So I might just want to write 3 pi here. Let's find out if we just write 9.42. It's okay with that. 3 pi probably would have also worked, but we did 9.42. Which of these quadrilaterals are rhombuses? Now remember, a rhombus, the only rule is all 4 sides have to be equal. It says that right here. All sides equal in length. Equal? No. Equal? Yes. Equal? Yes. And that's it. What is the area of the following circle? Remember that we just talked about this. Area is pi r squared. Either enter an exact answer in terms of pi or use 3.14 as pi and enter your answer as a decimal. We're just going to use an exact answer, right? We know, right, that it's pi r squared. Well, that's just 5 squared, right? The radius is 5. So 5 times 5 is 25. So our answer is just going to be 25 pi's, right? Because it's 5 pi times 5 squared. Pi times 25. That's just 25 pi's. Okay? And so we're just going to put in 25 pi. And it has a little button here for me for that pi thing. Okay? So 25 pi units. Check. Good to go. Here we have 7x minus 99 and 2x plus 1. These are equal to each other by vertical angles. Okay? So really what we have here is 7x minus 99 equals 2x plus 1. Add the 99 to both sides, and we have 7x equals 2x plus 100. Get rid of this 2x here. Get rid of it over here. Right? And we're left with 5x equals 100. Shouldn't be too much of a stretch for us to see x equals 20. And so we're going to put in, we're going to double check. 140 minus 99 is 41. 2 times 20 is 40, plus 1 is 41. So we're getting 41 for both answers. Oh, whoops. I put in the angle instead of x. So we're going to put in 20. Check again. Show summary. Now, this is what, if you've already done the practice quizzes and you've already done the practices, you can actually, if you got all of these right, you can actually just do the mastery test over and over again. Had I gotten it right, all of them right the first time, it might have just given me mastery in everything. I didn't get the one of them right? I didn't get the equation practice with vertical angles. And this one, yeah, in fact, it said I'm bad at this one. On all the rest of them, I went up. Some of them, I even went up, did I go up by 2 on any of them? Nope, I went up by 1. So it asked me one question from each thing. That's every standard, right? We can go ahead and look. This was a completely fresh, clean one. I hadn't done anything. And now, other than equation practice with vertical angles, I'm going to want to go and fix that. I have a rectangle in everything. Okay? So, yes, do make sure at the very end you do take the unit test. If you don't know something, that's okay. Go back. Watch the video for it. Do the practice, right? Nelsky just got this one wrong. Guy doesn't know anything about vertical angles, right? I can just do this practice quiz and make sure I'm comfortable with it and go, I don't want to make that same mistake. What did I do wrong? Work through this, right? Now I can see that 6x and 3x plus 178 equals 6x plus 238, right? Now I can see x is going to be 20, right? Because 60 plus, it's not going to be 20. Let me see. 3x equals negative 60, so it's going to be negative 20. Right? Because that would make this 118, that would make this 118. Check. Next question. Again, they're equal. 2x, right? I'm subtracting the 6x's. 2x equals 20, so x is going to be 10. Okay. 2x plus 103 equals 7x plus 68. Bring this over. 7x minus 2x is 5x. 103 minus 68, that's 35. 5x equals 35x is going to be 7. Right? Do these slowly. Work through them. 9x plus 210 equals 4x plus 140. Bring that over. I get 5x. Subtract the 210. I get equals negative 70. So 5x equals negative 70. X must be negative 14. Right? And before, right, I had a bad score on that one. Now it's telling me I'm good to go, right? This is the one I had wrong before. I only had one rectangle. Now I have two rectangles. If I get stuck on something, just go back and practice on it. If I'm so stuck that it just does not make sense, right? Watch a video, use the hint. Here's the video for this standard. This video should help me. I don't want to watch the video right now, so I'm just going to get a hint, right? Use the hint. I just don't know how to do this. Vertical angles are congruent. Oh, the angles are equal, duh. Right? That's not enough for me. Since they're equal, you can make these equal. Okay, but I forgot how to solve for x. Subtract 2x from both sides. Okay, I remember this now. And then, and then you're just going to get rid of the 49. Let me see if that's right. Yeah, and then you get rid of the 49. 5x equals 45. Oh, then you just divide both sides by x, or by 5, and then you get x equals 9. That's, okay, I should have known that. Right? There's nothing wrong with that. Yeah, I didn't get a point that time, but now I know how to do it, right? I get to the next one, I'm way more comfortable, right? 2x equals 38. X must be 19, right? I didn't need any help on that one. So work on these, mess around with them. If you're getting stuck, go back, watch the video, do the practice problems. But yeah, your goal should be to get to do the unit test and get perfect mastery. That's all for now. I will be making a few more videos during the week if there are standards that really bother several people. So if you're getting stuck, email me. Let me know. I will make more videos. I'll try to be as clear as I can. Also, I'll try to explain it in an email if you email me a problem. I will do anything I can to help you guys get the A that you want. I want you guys to leave my class with an A. And I'll talk to you later.